Good morning. Myself, Dr. Nishtay Pratibha, Associate Professor, Department of Chemistry, Hindustan College of Engineering and Technology. Today, I am going to share about a topic, metallurgical coke. So, the content of the presentation is what is metallurgical coke and what is the difference between coal and coke, what are the types of carbonization process of coal and the manufacturing of metallurgical coke. First, the coke is said to be a solid fuel which is used in a metallurgical purpose. We have to see what are the requirements to behave as a coke as a good fuel. First one is purity. It should have lower percentage of moisture, ash, sulfur and phosphorus content, then only it will give a good calorific value. Second one is porosity. The coke should be have highly porous, then only it can the oxygen can come in contact with the porous coke and it will give a complete combustion at a higher rate. Third one is strength. The coke should be quite hard, compact, hard, strong and should withstand the higher pressure as well as abrasion resistance it should have. Fourth one is size. The size of the coke should be neither too big or not too small. For fifth one is cost. It should be economically cheap and easily available for making the metallurgical purpose. Next one is combustibility. Coke should burn easily and it should give higher combustion and it should give higher calorific value also, and it should have low ash, sulfur and phosphorus to avoid the unnecessary incomplete burning process. The reactivity towards steam increases with the reaction temperature. What is the difference between coal and coke? Actually, coal is also a solid fuel and coke is also a solid fuel. What is the major difference? Means the coal strength is very low when compared to coke. Coal is a soft solid fuel, coke is a hard solid fuel. And the undesirable sulfur content, ash content, phosphorus content will be very low in coke when compared to coal. And coke will burn in short flame and it give very low volatile matter only when compared to coke, because the coke will burn very long flame and it gives higher volatile matter to the environment. So only the coke is preferred when compared to coal for the metallurgical purpose. If we compare the quality of the coke and coal, the coals which on heating in absence of air it will become soft plastic in nature, but the coke will be very strong when it is in contact with the air, oxygen. It will be hard, strong and durable, which is used for the metallurgical purpose. Next is carbonization process. What is carbonization process? It is nothing but burning process. We have to convert the coal into coke. What is the main thing is carbonization process. There are two types of carbonization process to convert the coal into coke. One is low temperature process, another one is a high temperature process. Low temperature process is nothing but it takes temperature nearly 500 to 700 degrees Celsius, and the yield of this process will be 75 to 80% of coal will be converted to coke and only 5 to 15% is converted as a volatile matter, and it is not mechanically strong product during the low temperature carbonization process. The coke obtained is suitable only for domestic purpose and it is not suitable for metallurgical purpose, whereas the high temperature carbonization process carried out at 900 to 1200 degrees Celsius, and the product will be higher, it gives a higher calorific value, low volatile matter, and this can be used for the metallurgical process. Next thing is manufacturing process of metallurgical coke. How the industries are manufacturing this means there is a method called as Otto Hoffmann's byproduct oven method. This method is used to convert the coal into coke process, and in order to increase the thermal efficiency of the carbonization process and to recover the valuable byproducts like coal, gas, ammonia, benzene, oil, tar, naphthalene, etc., this Otto Hoffmann's byproduct oven method is preferred to undertaking the process of manufacturing the coke from the coal. And there is one more thing is there, using this method the regenerative system of heat economy is followed. That is the fuel which is taken will be very low, and it is a conservative method also. This is a block diagram of Otto Hoffmann's byproduct oven. You can see here, this is a block diagram, how the coal is getting converted to coke was represented in this diagram. This is a main chamber of the Otto Hoffmann's byproduct oven. There are 4 chambers are there in the top. Inside these 4 chambers, coal is filled, and the lower part you can see the inlet 1, 2, 3, 4. So 1 is the outlet of the waste gases, and 2, 3 is the inlet of the fuel gases like air and producer gas, which increases the temperature inside the oven. And inside the oven the temperature is getting increased, and during that time the coal which is present inside the 4 chambers will be converted to coke, and during that process a coal gas will be also liberated on the top, and bottom, that is number 4 outlet, you can see flue gases will be liberated from the oven. That flue gases will be collected in those towers to recover a valuable byproduct. And one more thing, why we are telling it is a heat generative of an economy system, why we are telling means, you can see here whatever the heat which is produced from the 2 and 3 valve, which is getting circulated around the chamber, and again it is reused, it is coming to the 1 and 4, and again it is getting regenerated, and it is going back and surrounding the particular chamber to produce the coke. Okay, so the heat generator will be an economic manner, because the hot regenerator 1 and 4 is the hot regenerators which reheat the outlet air, and again the gas burns and it's circulated around the chamber. And you can see through a valve 4 the flue gas is getting liberated, and it's going each tower. It is getting one by one tower. First tower, the flue gas is allowed into the first tower where tar is recovered. Okay, so in that top you can see the gas first enter into the tower in which a liquor ammonia is getting sprayed, so thus the tar is getting liberated. Second, again the flue gas is entered to the second tower in which normal water is getting sprayed so that ammonia will be recovered. And third tower, the flue gas is entering in which a lowest temperature water is sprayed so that naphthalene is getting liberated. Then fourth tower you can see the flue gas is passed, and you can see petroleum is getting sprayed on the top, so benzene is getting liberated. The last one is the flue gases enter to the last column in which Fe2O3 is getting sprayed, so the hydrogen sulfide is getting retained on the last tower. So these are the valuable byproducts also obtained apart from the coal is getting converted to coke, and the regenerative system of heat economy is also followed for producing the coke from the coal. So this is the setup from which we are producing coke, as well as we are producing many valuable byproducts like tar, ammonia, naphthalene, benzene and H2S from this process. So thank you so much for listening my video. Thank you.